Alright, boys and girls, as you can see, I'm not here today, so what I need you to do is you need to watch today's video. You need to make sure you take all the notes. When you are done with the notes, you can check in with your sub. If you show her that you have your notes and you've watched the video, she will give you the homework. Alright, so what we're doing is today we're working on Radicals 2. Our warm-up shows us 2 times x plus 6. This should be pretty simple for us as a review. I would be multiplying by the 2, and I'm going to distribute it. 2 times x is 2x, and then the 2 times the 6 is 12. Final answer would be 2x plus 12. Going ahead, and I'm timesing by x on this one. So x times x squared would give me x to the third. Remember, multiplying variables, you add the exponent. X times 2 gives me 2x. On number 3, what I would go ahead and do, and this is just me personally, I'm going to use the commutative property of multiplication. I'm going to switch these. I'd rather say negative 3 times x plus, sorry, I'm going to change this just real quick as well. X squared plus x. Remember, we want to do standard form where right here I want to put my exponent that's the largest number first. So I'm going to say negative 3 times x squared gives me negative 3x squared. And then I'll have negative 3 times x is negative 3x. Okay, very last one. I use purple. I'm timesing by 0.1, and once again I'm noticing, hopefully you caught it, that is not in standard form, and it's okay, but I'm going to go ahead and switch this. So I'm going to rewrite this problem so it's 0.1 times 10x plus 6. Now when I multiply 0.1 times 10x, well, that would come out to just x. It's 1x, so I can just say x. And 0.1 times 6 will give me 0.6, or 6/10. On number 5, the area of a square field is 148 square meters. What is the side length of the field? Very first thing is I always draw this. Ooh, and actually I failed at my drawing because I drew a rectangle and it says it's a square. Remember, the important thing about a square, all my side lengths are the same. So it doesn't tell me about the width of my field or length, so I can use a variable, and I know they both are going to be just x. With a square, my sides are the same. The way we find area is length times width. Area is length times width. But with the case of a square, it'd be area equals, and I'm going to say x squared, because x times x is x squared. Well, they told us the area. So I would say 148 equals x squared. We undo squaring by square rooting. And I would get my final answer to be x equals, I'm going to pull up my calculator. We do 148 and I square root it. It's going to come out to be a non-terminating 0. So I'm going to round to the nearest tenth, which would be 12.2. So I'm going to say, oh, did it tell us? Yep, they didn't tell us what to round to, so I'm going to say 12.2 equals x. What is the side length of the field? My answer should be 12.2 meters. Okay, make sure you have those down in your notes and that you understand them. Today our learning goal is I will rewrite radical expressions in simplest form using properties of radicals. Reading through this quick, we're not putting it into our foldable, it's okay. A radical expression is in simplest form if the following conditions are true. So no perfect square factors other than 1 are in the radicand. No fractions are in the radicand. No radicals appear in the denominator of a fraction. You can use the following property to simplify radical expressions. Words, the square root of a product equals the product of the square roots of the factor. In algebra, I'm going to zoom in on this, hopefully. So the square root of AB is equal to the square root of A times the square root of B. So if I had, what is the square root of 4x? I could break that apart and say, what's the square root of 4 times the square root of x? Well, the square root of 4 we know is 2. And I cannot do the square root of x, so I'd be left with 2 times the square root of x. I did a little bit of that yesterday in our warm-up just to preview this lesson. So hopefully that will stick with you today. Let's try this. In our example, we have the square root of 32. And I'm just going to go ahead and show you, if I was to put in square root of 32, it does not come out. So what we are going to do is we are going to factor using perfect square factors. Remember, perfect square factors are like 1 squared equals 1, 2 squared equals 2, 3 squared is 9. Oops, sorry, I just caught my mistake. 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. The ones over here are the perfect square factors that we're looking for. So when I took the number 32, the way I like to show my work is I have the square root of 32. And I'm going to use like a factor tree. And I'm going to change this out. And I'm going to say, what are 2 factors of 32? What are 2 numbers multiplied together to give me 32? And I can use anything I want. Well, they happen to notice the largest one was 16. So 16 times 2. And then we say, can I know the perfect square? Since I used the perfect square, we break this one down to 4. Square root of 2, I cannot factor that down anymore. That's a prime number. There's nothing else I can do to it. So it stays alone. So I just put it in my answer. My final answer is 4 times the square root of 2. Now I am going to show something, excuse me, real quick. What happens if I use something that's not the largest perfect square? Like, I happen to know the square root of 4. I know 4 times 8. 4 times 8 is 32. Well, square root of 4 comes 2. But when I look at the square root of 8, I can break the square root of 8 down still. That's still factors. I can factor that down to the square root of 4 times the square root of 2. Square root of 4 is 2. Square root of 2, it's done. That's as far as that one goes. It's a prime number again. I'm left with this number, and this number. So I'd have 2 times the square root of 2. And if we simplify, 2 times 2 is 4 times the square root of 2. We'd still get our same answer. Okay, looking at B, I'm just going to look at how they did this. It's kind of blurry, I'm sorry, but square root of 9 times x to the 3rd power. Well, I can make this square root of 9, and instead of x to the 3rd, here's the awesome thing about exponents. When we find the square root, we just have to make them an even number. X to the 3rd, I'm going to draw it right here. Square root of x to the 3rd. That is an odd number, an odd exponent. So when I factor, all I have to do, this is so simple, is I have to subtract 1. X to the second power and x. So I broke 3 into 2 plus, this is really like x to the first power. Because x squared, if I square that, I would just get x. And I'd be left with the square root of x. So x to the third power simplifies to x times the square root of x. Don't forget we had the number 9. 9 squared is 3. So then I put my 3 times my x times my square root of x. We'll do a couple of these real quick. First one. What is the square root of 54? Okay, well, first thing I can do is, I can do this a couple ways. If you like, I could list the factors of 54 out. 1 times 54. 2 times 27. 3 doesn't go into it. 4 doesn't. 5 doesn't. 6 times 9. And what I would look for is I'd look and say, are any of these a perfect square factor? Okay, 54. I'm going to start with my largest number because I want the greatest one. 54 is not. 27 is not a perfect square. Nothing times itself gives me 27. 9. Yes. So I'm going to break square root of 54 into the square root of 9 times the square root of 6. Square root of 9 becomes 3. Square root of 6, because I use my largest perfect square, I know I'm done. Square root of 6, the only factors besides 1 and 6 are 2 and 3. I don't know the perfect squares of any of those. So this just becomes, that's the end of this one. So when I get my final answer, I do 3 times the square root of 6. On number 2, I have 7 times the square root of 20. I'm going to take this 7, I'm going to switch colors, and I'm going to bring them down here. I'm going to work with that a little bit later. I first have to find the square root of 20. So like I did before, factors of 20. 1 times 20, 2 times 10, 4 times 5, and that's all of them. I start at the largest number, 20. 20 is not a perfect square. 4 times 4 is 16. 5 times 5 is 25. 10. No. So I can even cross these off. 5. No. 4. 4 is a perfect square. So 20 is going to be broken down to the square root of 4 times the square root of 5. Square root of 4 is 2. 5, square root of 5, can't break it down anymore. Here's where this comes into play. So I had 7, which was my original number, times 2 times the square root of 5. 7 times 2 is 14. And when we times by the square root of 5, it's left alone. Hopefully we're catching on this. Number 3 looks a little more tricky because it has a fraction. Nothing changes. I'm just going to take this fraction. I'm going to put it down here for right now. And if I use the right number, that'd be even better. Alright, so 2/5 times. I have to find my factors of 75. Did my number bad. So I'm going to go over here. Factors of 75. 1 to 75. 2 doesn't go in. 3 times 25. 4. 5 will go in. 5 will go in. 1, 15 times 6, 7, 8, 9, and believe, no, feel like, oh yeah, that's it. Sorry, I kept checking 15 and 5. Okay, so now I have to look for my largest perfect square. 75? No, nothing. No, 8 times 8 is 64. 9 times 9 is 81, so no. 25? Absolutely. 5 times 5. So I'm going to say square root of 25, and its factoring partner is the 3. So times the square root of 3. Square root of 25 is 5. Square root of 3 is left alone. And now when I do a fraction, since this is a fraction, I'm just going to make 5 over 1. Remember, anything over 1 is the same. When I break down here, 2 times 5 is 10, and 5 times 1 is 5. Before I do anything else, I notice this can be simplified. 10 divided by 5 is equal to 2 whole. I still have this times square root of 3. So there's my work. The 2/5 times the square root of 75 will simplify down to 2 times the square root of 3. Alright, I'd like to work on a few of these, and then I'm going to tell you to pause your video, do the final 2, and then check. So, actually, if you'd like, you can pause your video right now, do the work, scroll ahead, see if you have the right answer. So, please pause your video right now, see if you have, try and do the work by yourself, and then check your answer with mine. If you need to scroll ahead, you can, and then all you have to do is come back. Alright, so real quick how I did this. I still am going to leave my 4, and I'm going to look at the square root of c to the 7th power. Well, if I do that over here, remember, all I have to do is break that into c to the 6th power. I'm sorry, I don't know why my pen's not working right. And c to the 1. Sorry, OneNote's not writing on there. All I have to do is take that exponent, if it's an odd, subtract 1, and I do 6 and 1. Square root of c to the 6th is c to the 3rd. And I'd still have square root of c. I have a 4 here, so I have to times that to here. And my final answer would have been 4c to the 3rd times the square root of c. Number 2. It's a negative exponent. So I'm going to change this to x to the 4th power and x to the 1st power, or just x. All I'm doing is taking my odd, subtracting it by 1 to get an even, and keeping a square root of 1 there. X to the 4th becomes x squared, and this one's left alone, so square root of x. 3. Okay, so I'm going to break this apart. I'm going to have the square root of 5 times the square root of a to the 3rd times the square root of b. When I look at the square root of 5, I do my factors like we did before. All we have is 1 and 5. So I can't break that one down anymore. I am done with it. I'm going to highlight it to show I'm done with it. Okay, a to the 3rd, I'm going to break down to square root of a to the 2nd power times the square root of a. A squared becomes a, and square root of a is left alone. So I have a times the square root of a. I'm going to go to my b. Square root of b. Well, I only have one b. I can't subtract 1 from it. So that's my final answer. It cannot go down anymore. When I go to multiply these, I'm going to put these in order. I have an A on the outside. Inside my square root, I have a 5. I have an A. And I also have a B. The square root of 5a to the third b would simplify to a times the square root of 5ab. Remember, I can times the 5, the a, and the b. See if this helps. I can times those because they are all inside our square root sign. So they have like a like base, if you would. Last one. 4 times the square root of 47. Well, 4 is on the outside, so I'm going to bring that down here for my final answer. 4 times. And when I do the square root of 47, I need to identify my factors of 47. Oops. Factors of 47. Well, if you haven't figured it out yet, 47 is a prime number. Well, so if it's a prime number, I don't have a perfect square, which means that is already simplified. That's already on the outside. My final answer is 4 times the square root of 47. We didn't change it at all. Sometimes we will get these radicals that are already simplified. Alright. Hopefully you have your notes done. Make sure you show them to the substitute. If you have any questions, make sure you can ask for help. You are doing worksheet 2, 1 through 34. Please do this on a separate piece of paper. You do not have room to do it right here on your little half sheet that she's giving you. You must show your work. Your work should look exactly like we've been doing all these problems. Find, especially here, where we found the factors, we use those here, and then we put in our final answer. Alright, have a great weekend. I'll see you guys on Monday.